So for the first question here, this is the line type of question. So as per usual, the first thing that we need to calculate is the gradient. So I labeled y2, y1, x2, x1 and run the gradient calculation, and I gotten 10. So from this, I can now construct the line equation. Y equals to mx plus c. The y is now our root of 4y, and then our x will now be changed into 1 over x. So they say that it passes through 0.5 and 9, 3, 34. You can randomly substitute whatever that you like. So in my case, I substituted 3, 34 into the x and y's position. Okay, remember, you don't have to put it as root of 4, 34 and also 1 over 3. Reason being, they say it passes through already. So which means the value itself is already 34 and the x is 3. So after the calculation, you gotten c equals to 4. So your entire equation can be written as y to the root of 4 equals to 10 over x plus 4. And to get rid of the root of 4, I just bracket the other side of 10 over x plus 4 to the power of 4 to find y as a function of x. So this action will cancel off the root that was existing over there, and you get your final answer. As for question 2, this is actually the completing the square. So first thing that I did was to extract 9 from all the variables over there. So immediately I know that my p is actually 9. So as per usual, I only focuses on the two variables at the front. I gotten my x equals to a, so my 2ab equals to negative 12 over 9x. So I substituted x into a's position and divide them off. Your b's final value will be negative 2 over 3. So with this being said, okay, we can now proceed and identify our r. So just to let you know, q is valued at 2 over 3. I didn't include a negative because it has a negative existing over there already. So to find your r, all we need to do is to use the remaining integer value that we didn't use and minus off whatever that we added in. So the 9 will be multiplied with 5 over 9. Okay, in order to take it out from the bracket. Then minusing off with the variables that we just added in. Okay, we added 2 over 3 square, so you're required to minus off negative 2 over 3 square over here. And do take note that you need to multiply it by 9 because it is outside of the brackets. So your final r value will be 1. So your p is 9, q is 2 over 3, and r will be 1. Hence, write down the coordinates of the minimum point of this curve. So you take the x minus 2 over 3, okay, equals to 0. X will be 2 over 3. And the corresponding y value, when you substitute 2 over 3 into the equation, you will get 1. So the coordinates of the minimum point will be 2 over 3, 1. For question 3 that we have here, okay, this is polynomials question. So find the remainder when it was divided by x plus 1. So you run the basic calculation. Do take note that the upper value and the lower value is having a minus relationship. So you have to put a negative bracket in order to get to the next results or the balance that you have there. So your final remainder will be 24. The details working is as shown. As for B part 1, show that x plus 2 is a factor of it. So when x equals to negative 2, you substitute it into the x position, you will get 0. So if there's no remainder, it means that it qualifies as a factor. Write it as a product of linear factor. So since we know that x plus 2 is the factor already, we can first divide them off, and you will get 15x squared minus 8x plus 1, and through factorizing it, you will get it as x plus 2 multiplied with 3x minus 1 multiplied with 5x minus 1 as your final answer. So for question A, section A over there has 5 questions in total, and question B has 8 questions in total. They want us to select 2 and 4 out of it, so it'll be the final answer will be 5C2 times 8C4. So this will get you 700 as your final answer. As for part B, slightly tricky. So since they gave us all the numbers that we can select from, I'll be using NPR for this, and there's a special restriction on the last digit because they wanted this 7 digits numbers to be even. So out of the numbers that I get to select, only 2, 6 and 8 qualifies as an even number when it was placed at the last slot. So immediately I write down 3P1 for that. And for the remaining space, I'll be using 6P6 to represent it. So your final answer after multiplying it will be 2160. As for question 5, vector question, okay, multiply the 4 into the information, the A negative, B over there. You'll be getting 4 alpha by this 12 bracket I plus 4 by this beta J. So this is after I rearrange all the I's together and J's together so that I can run the comparison. So our 4 alpha minus 12 will be compared to alpha plus 3. As for our 4 minus beta will be compared to minus 2. So through this, you will get your 3 alpha as 5. As for beta part, it will be negative beta is negative 6. Beta, your final answer will be 6. Hence, find unit vector in the direction of b minus 4a. So I first calculated b minus 4a first. Substitute beta and alpha value that we identified. You get 2j minus 8i. So 2j minus 8i over the Pythagoras theorem, square root of 2 square plus 8 square. You'll be getting 2j minus 8i over 2 square root 17. So for this, I didn't rationalize it, and it is acceptable only for unit vectors chapter. Okay, for question 6, all I did was to substitute kx minus 7 into the y's position and then run the rearrangement, make it equals to 0. So I gotten my 3 as my A, 8 minus k as our B, and C is 12. So I substitute it into the b squared minus 4ac's formula. I gotten it as k squared minus 16k minus 80, and after factorizing it, you'll be getting k plus 4 and k minus 20. So for this, since they wanted does not intersect, means your b squared minus 4ac results is less than 0, it will be referring to this intersection part, okay, that is lower than the line y equals to 0. So your final answer will be k less than 20 more than negative 4. As for question 7a here, this is actually a logarithm question. So I first change everything into a base of 10. Okay, and since logarithm, the default is base of 10, I can choose to just write log over there. So I got the log 5 equals to x plus 2y. Okay, then I rearrange it as x equals to log 5 minus 2y. As for the other part, I'm rewriting log 50 equals to 3x plus 4y. Substitute the x position with log 5 minus 2y and run the calculation. I'm getting 2y equals to log 5 cubed over 50. Please take note that if log and log, their relationship is minus if we translate into divide. Okay, so through this calculation, I'm getting 1 over 2 log 5 over 2. If you were to write in decimals, make sure you write it in full because they wanted it to be in the exact simplified form. So when you saw the keyword exact, it's best if you can write them in fraction or simpler way that you can figure out. So through this, I substitute my y's value into the equation 1 that we have there. Your final answer would be log 2, or if you were to write it as decimals, as mentioned earlier, you have to write everything that you gotten from your calculator. As for part B, personally, I prefer to swap out the x to the power of 1 over 3 here into something else to avoid any confusion in the calculation. However, you can still remain it unchanged and just write it as 2 x to the power of 1 over 3 to the power of 2 minus x to the power of 1 over 3 minus 10. It's all totally optional, up to you. You can choose whatever that you wanted. So how do I know I have to use x to the power of 1 over 3 over there? It's actually through the little information that was given. So you have to try to analyze what's the relationship or what was repeating between the x. So in our case, immediately at first glance, after you practice enough past year, you should be able to identify that x 1 over 3 was the one that was repeating. So you should be getting x to the power of 1 over 3 equals to 5 over 2. In order to make it back into x to the power of 1, I multiplied both sides with 3. So 5 over 2 being cubed, you'll be getting 125 over 8. As for the other one, x to the power of 1 over 3 equals to negative 2. After cubing it, you'll be getting negative 8 as the final results. As for question 8a, we'll be using binomial expansion on this and expand it to the simplest form. Okay, so you should be getting 32 minus 80x plus 80x squared minus 40x cubed plus 10x to the power of 4 minus x to the power of 5. So whatever that you see here should be pretty straightforward. I'm just substituting it into the formula that was given at the first page. As for part B, okay, you'll be using your indices rule here. So I first transform multiply into plus and divide into minus. After the rearrangement, you should be getting negative 40x cubed plus 80x squared equals to 0. I get rid of the negative by multiplying negative on both sides, and I extracted 40x squared from it. So the balance that we should have in the bracket will be x minus 2. So your x final value will be 0 and your x will be 2. As for question 9 here, so you're required to illustrate out whatever that was given. So I know that 60 seconds is a flat straight line over there. So it took 15 seconds to complete the velocity to 1.6, so there was a downward slope. Then 5 seconds, which is from 75 plus 5, you get 80, and it decelerates to 0. So through this, calculate the distance between O and A, means the area of this two trapezium shape, I would say. So in our case, I split it into one rectangle, one trapezium, and one triangle to get the calculation done. So I took 60 times 3 plus half. The top will be 1.6, the bottom is 3, so 1.6 plus 3 multiplied by the height of 15. So that's for your trapezium calculation. And the last part is the triangle over there, 1 over 2 times 1.6 times 5. So your final answer will be 218.5. As for part C, finding the deceleration here, so I'm taking the coordinates and run the calculation. I got a negative 0.32, but remember for speed, there's no negative. So the deceleration will be there to help us to take out the negative. So final answer will be 0.32 meters second squared. As for question 10, so to find A is pretty straightforward. All you need to do is to substitute when y equals to 0. So your x will be 3. So your A's coordinate will be 3, 0 over there. As for your B, okay, it's the intersection. So I substituted 4 into either one of the equation. So in my case, I use back the same equation that I used to find A. So get rid of a square by putting square root. So you have plus minus 2 over there. And your x value will have 5 and 1. So this basically tells us that the 5 is not suitable for this because it is not the first intersection. Okay, it may be another intersection at the back. So 5 is not suitable and I will be selecting 1. So your B's coordinate will be 1, 4. And through this, they are asking us to calculate this shaded region, which is the center over there. So I'll be taking integral of 1, 0 for x to the power of 2 over 3, adding it with integral 3, 1 bracket x minus 3 bracket square. So after the calculation, I know that the 4x 2 over 3 after integration, you get 3 over 5 times 4 x to the power of 5 over 3. So I actually listed the details calculation over there. You can just refer to it if you need any help on this part. As for the one at the back, it's pretty straightforward, so I didn't include any workings for it. So through your calculation, you should be getting 5.07 after correcting into 3 significant figures, or 76 over 15. As for question 11, fx equals to ln 2x plus 1, okay, where x more than 0. So this part here, I actually draw it out through having this table over here, when x equals to 0 and when y equals to 0. Okay, and I put some extreme value to verify the calculation. And this is how the function graph should be looking like. Find an expression for G inverse and states its domains and range. So first, before proceeding, I will always check what's the original domain and range over there. So the original domain was x less than equals to 4, and the range of it will be gx more than equals to 1. So remember, when you're looking for G inverse, basically you just change the original domain into range and original range into domain. So domain now will be x more than equals to 1, and for your G inverse, it will be less than equals to 4. So next part, to find G inverse as per usual, step 1, swap the x and y's position, rearrange everything and find your new y. You should be getting y equals to negative square root x minus 1 plus 4. The reason why I selected negative instead of the positive one, because they wanted the G inverse over there to be less than 4. So don't take the domain and range lightly, because they actually play a crucial role here. Because you can't decide whether to put a plus or minus in front of the square root without this information. And you couldn't secure the full marks if you miss out this little detail. As for part 2, simplify the expression of f gx. Substitute gx first, you should be getting x minus 4 bracket square plus 1, and this entire thing is your new x. Okay, substitute in your function y, you should be getting ln 2x squared minus 16x plus 35. Explain why function gf doesn't exist, because some of the value in the range of function f are outside of the domain of function g. Means that this is not possible. Question 12 here, find the stationary point of this. For this question here, we use a product rule. Okay, so I listed down ux and vx over there. Your u prime will be 3e to the power of 3x, and v prime will be 6 bracket 2x plus 3 to the power of 5 times 2. So this is actually a shortcut where I first transfer the power out, copy back the bracket, minus the power by 1, and then differentiate the value inside the bracket. So 2x plus 3, after the differentiation, you should get 2 only. So your v prime final results will be 12 bracket 2x plus 3 to the power of 5. So dy dx calculation will get you 3e3x bracket 2x plus 3 to the power of 5, and have a balance inside the bracket of 2x plus 7. So when it is equals to 0, okay, your 3x equals to ln 0, that one will be invalid. As for the other one, your x will be negative 3 over 2, and for the last bracket, you'll be getting x equals to negative 7 over 2. So this will be your x coordinates for the stationary point. So for part B, it wasn't linked to the previous question. Please take note on this. So d2y dx2 of function f will be 4x minus 7. And when your x value of dy dx of function x is 0.5, it will be equals to 0. When it is 3, it will be equals to 0 as well. So when I substitute 0.5 into x position, I will get it as negative 5. And when I substituted 3 into the d2y dx2 of function f, you'll be getting 5. So the results, if it's a negative, it will be your local maximum, and if it's a positive, it will be your local minimum. So that's pretty much it for this part B here. It's more towards fundamentals instead of calculation, because you need to know what to substitute into d2y dx2 to determine the nature. So substitute the x and check whether they are positive or negative. Then you should be able to identify which one of them is local maximum, which one of them is your local minimum. As for part C here, the volume is 40 cm cube. You get this 40 cm cube by taking 4x multiplied with x multiplied with h. So your h result should be 40 over 4x squared, which is 10 over x squared. As for your surface area, you're basically calculating everything. 4x times h times 2, because there's 2 sides that was repeating. X times h times 2, because there was 2 sides as well. And the last one, 2 times 4x squared. So through this arrangement, you should be getting 10xh plus 8x squared. There's a reason why I calculate the volume at the start, because from the volume part, I should be able to find what's our h and substitute it and make the surface formula into a single unknown only. So by substituting the h as 10 over x squared, I'm getting 100 over x plus 8x squared. So ds dx is negative 100 x to the power of negative 2 plus 16x. When it is equal to 0, by x value will be cube root of 25 over 4. And from this, you should be able to find your surface area, the minimum value of it, as 81.4. So that's how you get this calculation done and secure the 5 marks of this. They actually recycled this question from 2014, an earlier paper. So it is best if you look back to the older papers, because IGCSE do have a trend of recycling older papers instead of the more recent one. So please take note on these little details, and I wish you all the best in your upcoming examination. Thank you.